Before we can talk about probability distributions, we just want to kind of remember what a random variable is. And it's going to be important that you don't overthink it because we've been dealing with random variables, we just haven't been thinking them as being variables in the realm of probability here. It says a random variable is a variable whose values are determined by chance. And remember, when we talk about variables, we can break data up into two things. Qualitative, if we want to do something sorted by color or something like that, or what's the probability that you grab a blue marble out of somewhere. Or quantitative, and this is when you can have numbers, you can give it values. We can break quantitative up more into discrete and continuous, and really the difference there, they're both falling within a range, but discrete means we can count it. Continuous means, hey, it's going to be between temperature. It's going to be between 10 and 15 degrees, but we might have half degrees or, small degrees is in there. Whereas discrete, basically, how many blue cars are there? It's something you can count. So when we talk about a random variable, it says let's find the probability of tossing 3 coins. If we toss 3 coins, the first coin is either going to come up heads, I should write heads, or tails. The second coin is going to come up either heads or tails, and the third coin is going to come up either heads or tails. So this heads or tails here, we're going to refer to that as x, our random variable. Variable whose values are determined by chance. Okay, so if I wanted to say probability of, okay, for tossing 3 coins, and we're talking about coming up with heads, okay, our random variable is going to be that it comes up heads. So here's what we have. If there's no heads, tail, 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 our probability is 1/8 because there's one time it's going to come up all tails. I shouldn't say one time it's going to come up, but one chance that it's going to come up. And there's 8 total because we can have all tails, we can have all heads, and then we can have a combination of the two. So if we wanted to find the probability of this, we could say, what's the probability of having 0 heads? Well, just 1 out of 8 because there's only one outcome. These are a list of all the outcomes that have no heads. How many have 1 heads come up? Well, 1, 2, 3. So there's 3/8 because there's, again, 8 total outcomes. 2 heads, 1, 2, 3, and 3 heads, 8 heads, heads, heads is 1/8. So when we're talking about probability distributions, that random variable is kind of what we want to have happen, and we can take our total outcomes and figure out the probability of each thing happening. So let's look at an example. Well, before we get to example, a discrete probability distribution consists of the values a random variable can assume and the corresponding probabilities of the value. This is a discrete probability distribution. It's what the values of the variable are and the probabilities. The probabilities are determined theoretically or by observation. This is theoretically. It's theoretically because these are all of our total outcomes. We know that, and then we can figure out the chance of the different combinations coming up. Observation, that's when we're going to you have to get some data and observe something. Do some experiments, and we'll talk about that later. So, our example here, construct a probability distribution for rolling a single die. Well, our outcome, 1, 2, 3, 4, 5, and 6. Think about it. If you roll a die, you get a 1, a 2, a 3, a 4, a 5, or a 6 up. And that would mean, if I show you real quickly and really roughly here, and I don't remember what goes on all the dice, but I think I'm close. If I roll a die, one of these 6 things are going to come up. That means there's 6 total outcomes. What's the probability that a 1 comes up? Just 1 out of the 6. What's the probability that a 2 comes up? 1 out of the 6. 3, 1 out of 6. 4, 1 out of 6. 5, 1 out of 6. And 6, 1 out of 6. Okay, and this is just a simple probability distribution, but remember, that's what we're trying to do. Our outcome is x, our random variable. Okay, so we have a 1, a 2, a 3, a 4, a 5, or a 6, and then we can figure out our probabilities underneath. The way we're doing probabilities isn't different. The way we're thinking about them is. We're thinking of them in terms of distributions. We're thinking about them in terms of using a random variable. But the basic probability that we're going to find remains the same.